Please pause the video and take a moment to read this important safety message. Hey, and welcome back everybody. Part 3 here in our tube gear troubleshooting series that we started a little while back. I'm glad to get back to this series. And I thought I would today just walk you through, we've already done a few things. We've done a visual inspection of this, right? And we poked around some with a chopstick, make sure we didn't have any failing components. Always the first thing you want to do is a good visual walkthrough. Second thing we did was we brought the unit up on a variac, okay, and it came up. As a matter of fact, I'm running it right now at 116 volts, and we don't have smoke and things of that nature going on, sparks or whatnot. So far so good. But what we don't have, and I am feeding in right here a 1 kilohertz audio signal, and on the output here I'm getting nothing. So what I'm going to focus today's video on is finding the failing component. Alright, so the first thing I want to talk about is your best friend in electronics, and it's this device right here. Okay, I don't care what flavor of one you have, as long as it's not some super cheap model. It'll probably help you find what you're looking for. A lot of times I use that little ten-tec 330, which is like a $35–40 unit. This happens to be a Fluke 87V Model 5 version. It's just a spare unit I have around here because my main unit is upstairs. I'm troubleshooting a lamp I'm installing on the front porch that's not working, and so I just happened to grab this one today. But it is absolutely your best friend in electronics. A lot of people maybe can't afford a scope or don't do enough work to get a scope, things of that nature. It's fine. Matter of fact, I was talking to a tech probably a year or two ago, and he mostly worked on ham radio gear, but he was like the guy, right? Everybody in this area kind of goes to this person to get their stuff repaired, and he's on up in his 70s. And I was talking to him about how he went about troubleshooting, and he basically said, look, between an old analog digital multimeter and a new digital multimeter, that's pretty much all I ever use. He said, I can solve 99% of problems. If people will learn how to use one of these and use it properly, you will be able to solve 99% of problems. He said, matter of fact, my scope rarely ever gets turned on. And I believe the guy. He's been around the block a long time. So the reason that these are so important is you can start in your head to establish what I would consider a baseline for things. So one of the ways I learned was I just got a multimeter and I started testing equipment that does work. Okay, I would get in here and I would find out that, hey, across these 2 pins right here, that should be coming out of the power transformer. I should be getting AC voltage. And over here, across these 2 pins, according to the schematic, should be the filament voltage. So I should be able to see something like 6.3 or 12.6 volts. And I would measure this, and I would say, why am I not getting this here? And I'd trace back on the schematic, and I would figure it out. And what happens is, if you do enough of that over time, testing good known equipment where you do have a schematic for it, and you start to understand how things work a little bit, then when you find a unit that doesn't have a schematic, guess what? You're still able to troubleshoot it because you've got in your head a baseline of how things should work, okay? Alright, enough of me rambling on that. Let's dive into finding the failing component in this unit. Sorry, I'm going to do it to you. I got to rant for 1 more minute here, and it's probably more important than the previous rant I just got into. So I follow a lot of forums on the internet, right? And I read a lot of stuff about people repairing gear. And the most likely tendency that someone new into this hobby, or someone that's maybe even been in it a while but's not a total expert, their first tendency right now would be to come in here and say, well, I'm going to fix this by what I would call shotgunning, okay? They would come in here and they would replace this old, yeah, don't get me wrong, does this capacitor need to be replaced? Yes. Does this capacitor need to be replaced? Yes. Does this one need to be replaced? Yes. But people will come in here and do what I call a shotgun approach. They'll say, well, before I dive into the hard work of actually figuring out what's wrong here, I'm going to replace this cap, this cap, this cap, and this cap over here. Okay, so they shotgun, oh yeah, by the way, one over here, which is the infamous death capacitor. They shotgun this thing and they replace all the capacitors on it, right? And they're like, yep, I'm pretty sure that's going to solve the problem because this is an old unit and these are old paper and wax capacitors and they leak and they've caused problems and that's why this unit's likely not working, right? And if not, oh well, what the heck, I needed to replace these anyway. So it's a valid approach, it's just not my favorite approach. And so, you know, they'll go through and do that, and guess what? I can promise you on this unit, it would not solve a thing, okay? Not saying you shouldn't do it anyway down the road, but guess what? You may not learn something, or if you shotgunned it, and maybe this capacitor was bad, you really never learn that that capacitor was bad. So over time, you don't build up that baseline of going, well, you know what? This cathode bypass capacitor here is a typical likely failure point in these types of gear. And so, you know, you don't build up that baseline of knowledge because you take this shotgun approach to everything. So what my video is really focused on today is teaching you how to not shotgun gear. And how to go component by component, and let's find what's failing. Alright, let's start at the beginning here. Let's start at the power cord. You know, I'm plugged in over here in an outlet and I can see I've got 115 volts. Let's just get it up to 118.2 volts coming into this unit right here. Okay, sometimes when you find these units, older, this came out, you know, these were console kind of units. Sometimes they have not been jumpered on the jack here to enable them to have power to the rest of the amp without the socket being plugged in coming from the preamp or tuner section of the unit. And a lot of times what these console units will do is the power supply here will actually take in power here, feed it down into the transformer, right? But in between that, there is something in the plug here going over to the other unit that, as you turn the power switch on the unit, shorts and causes full conductivity through the fuse over here. And so often you solve that by soldering a jumper across two of these wires here, and then you no longer need to plug into, feed over into the main unit, and the power supply provide that short needed to provide continuity. So at any rate, I'm just going to kind of measure across a couple points here and see if we've got good power coming through this unit. So I can tell right here that I've got on one side of this and the other side, I'm at the power cord right now. You can see I've got my 118.8 volts there, okay? And then what I want to do is I want to come over here and I want to follow where it feeds out of this, and it actually feeds out right here. You can't actually see it. Flip it up a little bit. There's a gray wire right here that feeds out of this hot lead coming in from the wall, feeds over and goes into this fuse and then comes out the other side of the fuse. So one thing I might do is get onto this other wire here and then go to the top side of this fuse, and look at there, I've got 118.9 volts. So what I know is I'm at least feeding through that wire over and I'm making it through the fuse out the other side. Well, if you notice, that fuse comes out and goes down into the power transformer, right? And what happens over here with the other wire right here is I can see that it is jumpered over to this little connector, which then has a wire that comes around back here and feeds down into the power transformer. I can see here someone's already made the jumper needed to get power going down into the transformer. So at this point, I know I've got power feeding 118 volts going into my power transformer, right? So what I want to do then is look at the wires coming out of the power transformer over here, and there's really a couple sets here, okay? There's 3 red wires here that are a little bit corroded up with something on them. And then you got 2 wires coming out here, and if you pay attention, they all go to this rectifier right here. But Knowing that these are red wires here, and there's 3 of them, it's pretty easy to deduce, and you can find this by looking at any. This happens to be the schematic for this unit, right? Pretty much the output of any power transformer is on the. You'll have a primary wire here. You'll have another primary wire here. And then you will have a center tap that gets tied down to ground right here, okay? So this would be 350 volts, 350 volts. If you add those two together, guess what? You're up in the 700 volt range. You're feeding onto pins 1 and 7 here of this little rectifier tube. So let's look over here. These 3 red wires come out, and one of them feeds over and goes right here to a lug that is grounded. And I'm going to zoom in just a little bit for you, not too much, because I don't want to lose the perspective of the voltmeter here. So we're sitting right here right now with ground out of these 3, and then look, the other 2 here comes over here to pin number 7 right here, and this one feeds over here to pin number 1 and pin number 7 right here. Okay, so what does that tell me? If I'm getting power into the transformer, I should be getting power out of the transformer. I should be able to measure across these 2 wires right here, pins 1 and 7, right? I'm going to clip here on pin number 1, and I'm going to come over here and I'm going to clip here, pin number 7, just going to touch it. Guess what we've got? 748 volts. Why do I have 748 volts and not 700 volts like it says it should be right here? Here's why. I'm going to come back over here to the input of this unit, okay? Yeah, if I can find a good place to clip, I'm just actually going to clip right here. And I'm going to clip right here, okay? What do we have? 119 volts feeding into this. I'm going to go to my variac and I'm going to take this down to 110 volts, okay? Whoops. Okay, that's close enough. Keep in mind, when this unit was made, wall outlet power coming from your electrical company was around 110 volts. Guess what we got now? 689, 686 volts. Much more in line with the 700 volts, and maybe back then it was at 112 volts instead of 110 volts. Guess what? At 112 volts, we're sitting here with 702 volts out on this unit. So it's spot on. It's just history kind of getting you. And we can talk a little later about house voltages and should you try to drop the voltage any inside this unit or use a variac or something to power it with or whatnot. But the good news is I've got 700 and some volts coming out across this unit, right? Okay, now we've proven we've got 750 volts coming out of the power transformer feeding this rectifier. Well, guess what else comes out of the power transformer? Right, this set of windings right here. One side of these windings is grounded over here, right there, okay? The other side of the windings comes right here, and I'm going to clip onto that, and guess what we've got here? Yay! We have 6.3 volts, just what we need for the filaments of these tubes, right? Alright, so if we look at this unit here, it shows this 700 and some volts coming out here, right? It shows some windings coming out going into this socket over here. It also shows 6.3 volts that feed over here to this socket, right? And the reality is this 6.3 volt winding is used for 2 purposes. One, to feed the filaments of these 4 tubes, right? But it also feeds back over here into this socket, back out into the main power, the main preamp or whatnot, and it feeds the filaments over there. But we don't need to worry about that. We just need to make sure that we've got 6.3 volts feeding onto the filaments of all these tubes. And if you'll notice this, where this one was connected, it feeds a brown wire over here, and I could come over and connect onto the same little spot right here. And please guys, Never put more than one hand in an amplifier at any time. Keep your other hand away at all times. Okay, so we've got one wire feeding there, and we've got the other wire feeding right here. And if you'll notice, we've got 6.3 volts roughly feeding all these. Now, somebody may say, well, wow, that's 689 volts and not 700, or I saw you running at 750, isn't that going to be an issue? The answer is no. Tubes are very tolerant. They operate in a wide range of voltages, and you may just get a little more power out, you know, running them hotter, but guess what? It comes at a price. Tube life may be shorter, but these things do not need exact voltages. Okay, so on to the next step. We've now proven we've got output feeding out our filaments, we've got output feeding out our high voltage. Our power transformer is good. We can clap and celebrate that at this point, because that's the worst part. That the power transformer or the output transformer, if they're bad, we're in a mess of trouble. Everything else here is simply replaced and easily purchased without a lot of money. A power transformer, an output transformer, you may have to get somebody to rewind them, because finding original ones to go like this may be darn near impossible. So, we've proven we're feeding this rectifier with two things it needs, right? It needs filament right here, and it needs plate voltage here, right? And we've got both of those feeding into it. So you should be able then to come off here of the cathode of this unit, pin number 3, between it and ground, and you should be able to see somewhere around 400 volts of DC that has now been rectified coming off, which will ultimately feed into a filter capacitor with a CRC setup. So you got capacitor, resistance, capacitor here. You also have another resistor and another capacitor to feed some different voltages you need throughout the unit. But off of pin number 3 now, we should be picking up around 405 volts. And so, I'm going to swap out my lead here real quick with you guys on my multimeter to one that's a little bit easier to clamp onto ground here. And we do want to find a good ground to clamp onto, and this is a good spot right here because we've got several other things kind of clamped onto ground. And now we should be able to come off, what did I say, pin number 3 right here. And I'm going to flip this unit off of AC volts. That's what we've been measuring up to the rectifier, the other side of the rectifier, and we're now measuring DC volts. And I'm on to pin number 3. Guess what? I don't have any voltage coming out of pin number 3 here. If I don't have voltage coming out of pin number 3, my rectifier, I'm not getting any voltage anywhere else. Matter of fact, I can come over to one of these tubes here, and other than some filament voltage, I'm really getting nothing on the rest of anywhere here. So if my tubes aren't getting fed, tube amp's not going to work. You know what I've just deduced here? I have found our failing component, and if I'm not mistaken, if I flip this over, let me do this. I can see here, and I don't know if you guys can see it, I can see in the bottom of this tube, it is glowing. I can see the filament glowing on the top and bottom, the same over here and the same over here. This little 6V4 right here, I'm looking in the top of it, I'm looking in the bottom of it. I don't see a filament burning at all. And I've came to the conclusion that we've got a bad rectifier tube here, not feeding power through this unit, causing the rest of the unit not to work. Now, you could say to me, Mark, in the beginning you could have pulled all these tubes out and you could have put them on a tube tester and you could have tested them, and you would have found this quicker than you did this way. And you may be right, you may be right. However, I would have still, even after putting a tube in it, I would have still wanted to come back and check these voltages to make sure that my power transformer is working properly, that I've got the right voltages feeding into it, that I've got good filament voltage at the right level throughout these tubes. I would have still gone through these steps, but going this path, walk me through identifying the failing component. Let me go over and find another 6V4 and let's see if we can get this unit running. Alright here, so I was really bummed because if you'll notice, This is an old Amperex Bugle Boy, that made in the 20th week of 1957, 6V4 Easy 80, made in France. It's a beautiful tube, and I hate the fact that it's dead. But I went over and dug into my stash of 6V4s, and look what I found. I found a whole sleeve of new old stock Amperex 6V4s, and so I'm not feeling so bad, because I want to kind of keep this unit with some quality tubes in it. And there we go, brand new Amperex 6V4. This one's made in Germany. Oh, let's plug it in and see what happens. Alright, I've got it powered on, and guess what? Listen. We are starting to get audio out of this unit. And let's go back to where we were a minute ago. I'm going to kill the speaker on this. So we're just running off a dummy load. I'm going to go back and clip on the same place for ground here. And now let's get back into focus here. There we go. Let's come back over here to pin number 3 on this rectifier. Look at what we've got. 348 volts right here. 346 volts. And it is sounding good. Now, here we go. My house voltage fluctuates a little bit around here. At any rate, we're at 355 volts here. And you may say, well, wow, this thing said, you know, right here, 405 volts. Well, and it really has, it has not a lot to do with whether the unit will function or not, this and that and the other. Some of it could be, we got some leaky capacitance going on right here, kind of pulling this voltage down a little bit. So it could be that we're building up heat in this capacitor by dropping voltage across it. And by the way, I'm planning to replace this capacitor, this one, anyway, because this can cap, I mean, this unit was made somewhere in the late 50s, right? It's at least 60 years old at this point. These capacitors are electrochemical devices that they'll dry out over time and they will fail you. But what I'm excited about is we actually have sound coming out of this unit at this point in time. Alright, while we've got it here, we'll just wrap up here in just a minute, but let's check a couple more voltages. Let's kind of poke around this capacitor here, because that would be this little CRC network that we've got here, where we got 405 volts, then we're dropping some across this resistor. We should have a slightly lower voltage here. It tells us 390. Then we're dropping more across this resistor and gives us 355. So what I'll do is find where this red wire feeds over here onto this capacitor. And oops, there we are at what, 345 volts. Then what it does is it comes out of this, goes into this big wire wound resistor here, which then feeds over to this lug, which feeds back over here to this leg of the capacitor. And as you can see, we've dropped about 20 volts coming off of that. Then you can see we're feeding through another resistor over here to this leg, and that's where we drop down even more to 252 volts. And then at that point, we feed some of these tubes in here with this orange wire coming across, and you notice we feed over here and we go back out to feed the tubes in the preamp on the other side. So basically that's how we're feeding these preamp tubes. And you can see, you kind of follow that orange wire around then to different points in the amplifier, and you can see here where you're picking up the same voltage being fed to all these different tubes. So definitely things are working here. I definitely do want to replace this capacitor. It's just one of those things where the age of this unit. And then you kind of got to make some choices on do I try to find a can cap for the top here that mounts down in, or do I just stuff some capacitors underneath the chassis here and do it? And that's more of a cosmetic, aesthetic type decision than a true functional decision. But one thing to always look for, so when you have coupling caps, right, if you remember a coupling cap, what it does is, like, you'll have plate voltage here on this tube, right, of 275 volts coming off of pin number 1 of of this side of the 12AX7. And it's supposed to feed the, so you got audio signal coming in here, and it feeds out over here, and it also feeds out the cathode down through here. This is a phase inverter. But your signal coming out here is supposed to feed into this tube. Well, you're feeding into the grid of the next tube where you want 0 volts, not 275 volts. So how do you get rid of the, you got a little bitty teeny audio signal riding along this line, but you've also got 275 volts of DC. How do you get rid of the 275 volts of DC? Well, you get rid of that by putting a coupling cap in. So remember, capacitors, they allow AC to flow through them, they block DC. Okay? They're basically a high-pass filter of sorts, and they're blocking the very, very low, which would be DC. And so what you got going here, so a lot of times the way I'll troubleshoot a coupling cap is I'll put my voltmeter here on one side and I'll read the 275 volts, and I'll put my voltmeter on the other side. And if I have something greater than 0 to maybe 1 volt, then I probably got a leaky coupling cap, and these leaky coupling caps cause a lot of problems. A lot of times I'll have people ask me, hey Mark, this thing has some original, maybe Bumblebee capacitors in them. I want to leave those in them. I've heard they give it the original sound. Yeah, they do. They give it the original sound. And by the way, that 275 volts that's feeding 60 volts on the other side of that Bumblebee capacitor, because it's leaky, well, guess what? It's frying the grid on your output tubes. So as long as you're good with replacing output tubes every 3 months, go ahead and leave those in there for the original sound. And quickly they decide they should replace these regardless of the sound they produce. Now, so let's do that. Let's find one of these. Let's measure on one side and let's measure on the other side. So right here, what do we have? 161 volts on this side of this coupling cap right here, right? Let's measure on the other side. 0.06 volts. This is an old polypropylene capacitor, probably made by Mallory. It is a good one. Look at that. 0.06 volts on the other side of this. And that's probably grid leak current, grid leak voltage coming from the grid picking up electrons along the way. So it's probably not even leaking through that capacitor. But this one here, so somebody might have replaced this at some point in time and not this one, right? This one, let's read both sides of it, okay? Right here we've got, oops. What do we got? 66 volts on one side of this, right? Let's read on the other side of it. 17 volts. You do the math on that. That's a fourth, a little more than a fourth of the voltage provided on one side of this cap right here is leaking across, making it to this tube. What it'll ultimately do, it'll burn up this 6BQ5 output tube on this side, because you shouldn't have 17 volts on the grid. On the grid, what should you have? 0 volts. Okay, definitely why we've got to replace that one. So hopefully you even learn a little more today on how to troubleshoot a coupling capacitor. Alright, at this point you've learned a few things, right? You learned how to diagnose and kind of follow the power through the amplifier up through the rectifier, see what's coming out on the other side. You'd be surprised how many times just chasing the power I find the problem, okay? In this case, we did find it. It turned out to be the rectifier that goes right here. But what if it wasn't the rectifier? I have also taught you today how to troubleshoot coupling capacitors, right? Keep in mind, too, you did not have to go out and buy a high voltage capacitor tester to do that. What'd you do it with? Did it with a digital multimeter. How were you able to do that? Because you learned how a circuit works and you leveraged a schematic to figure out, even if I didn't have a schematic, I would know that one side of this capacitor should have high voltage on it, the other side going to the grid of this tube. I mean, you can always look up what kind of tube that is, right? Even without a schematic. And you can pull up the pinout out of a data sheet for that tube and know that this is the grid of that tube, and over here was the plate of this tube, and thus high voltage is here, and I should not have high voltage here. And we didn't. Over here, same thing. I should have high voltage, should not, but I did. So that's a problem, okay? Didn't have to buy a $200 or $300 fancy capacitor tester to tell me that. My best friend over here told me that because I understand enough about the circuit to figure these things out. All right, I'm going to leave you with one last little troubleshooting thing that you can do using your multimeter. And what I'm going to do here is, you can see I have pulled all the tubes out of this unit, okay? And I have then disconnected it from the power. And the reason I pulled the tubes, if you'll notice, like this resistor here, it goes from this lead. Let me zoom in and see if I can get kind of close to this. Okay, it goes from this pin right here on this tube over to another pin on this tube. Well, there's no other connection here. The only other connection to this little spot right here would have been the vacuum tube itself. And I don't want to measure something inside the vacuum tube. So by pulling the tube, this is a resistor that goes from this point to nothing, dead air basically, right? I'm now able to clip on one side of this unit here, right? And I'm now able to put my unit on resistance here, measure across it, 72 ohms across this resistor right here. Okay, so this is a blue, gray, black, silver resistor. You do the math on that. If you learn the color chart, that's a 68 ohm resistor, okay? And instead of 68 ohms, I'm measuring 72.1. One thing you'll learn, if you get this baseline of knowledge going in your head by testing older tube units, old carbon resistors like this, carbon resistors, float up in value over time, okay? And so this thing has drifted up from 68 volts to roughly 72 volts, but that's okay. It's only, what, we're out of spec right now, maybe 2%, 3%, something along those lines. We're not crazy out of spec on this unit. We're certainly not 10% out of spec. If this resistor was more than 10% out, I would then want to replace it, okay? And then we can just kind of float through the rest of these units over here. Okay, I'm trying to zoom in on it a little bit so you guys can see it, but it's a yellow, violet, and you notice you'll learn on these things. This violet color fades over time, so it doesn't really look violet. It looks pink. So you're going yellow, pink, yellow. I don't see pink on the chart, but it's yellow, violet, yellow, silver, and should be a 470 ohm resistor. And let me zoom back out here, and what are we getting? We're getting 513 volts over here, 514. So at 10% would be 47 ohms off, and 470, so 30, 40, 44 ohms. We're getting close to about 8 or 9% on this one. So this one I might want to replace, and I'll just keep walking through the unit. Now, you can't do that on every one. Like this resistor here, it's measuring across two parts of a capacitor, and if you measure across this, you're going to get the internal leakage resistance of this capacitor in this as well. And so you probably want to lift one leg end of this up to be able to test it. But a lot of these resistors, you're able to simply measure and determine whether they're in spec or not. So just another tip here, and it'll help you determine which things as part of your restoration you want to restore and which you want to leave intact. I was having a conversation with a guy yesterday at lunch about capacitors and resistors and what should we replace and this and that and the other. And I was telling him I like to leave these old carbon resistors in place if they are within spec, because that kind of gives it the original sound. If they're out of spec, not so much. These old resistors can also get noisy sometimes, so if you got some crackling, you can be getting thermal noise off of one of these. I'll leave it up to you. It's a religious debate on what you replace or not here. You could be safe replacing them with all new metal film. Then you get the metal film sound if you believe in that. If you don't, it's a religious thing, I told you. Almost. If you don't, then do what you want to do here. But hopefully you learned a little something on how to test capacitors, especially in the tube sections where you can pull the tubes, and typically the other side of them is connected only to a tube pin, and thus it's safe to test it. All right, we're going to leave you with that, and we're going to drop, and I think the next video will be on how to select the components that you go about replacing this in this unit. Thanks for watching, everybody. Hope you have a great weekend.